Thank you. So my name is Xiangbo Feng, and today I'm very happy to highlight some of the results in our work done recently in Reading. So this is this is a model evaluation work actually. So we evaluate the UK metal phase seasonal forecast system, S4-5, and see how well the model is in predicting the tropical cyclones in the West and North Pacific. So about the quickly introduction about the prediction system. Actually, this is not the operational system in the metal phase. Actually, this is the previous version of the metal phase seasonal forecast system called GLOS5. But the current version of GLOS is called GLOS6. We think the most results we found in this piece of work will be holding for GLOS6, so including the bias and also the variability. The model, the GLOS5 is has a 28 ensemble member for each month. So that's so the forecast covers about 6 or 7 months for each hindcast. So we look at the tropical cyclones from July to October in the hindcast period from 1993 to 2015. And so the tropical cyclone are tracked in the track algorithm, which is developed in the University of Reading. So the plot on the right-hand side show you the bias or TC frequency. So the top panel will show you the bias in the TC tracks. So you see there's a sorry, they're not bias, it's the climatology, right? So this is the climatology of the TC track in RB tracks and the ER interim, and also in GLOS5 June forecast. You see the big difference between models and observations. The lower panel show you the genesis density distribution across the whole ocean basin. You see there's a lot of the genesis, a lot of TC that happened in the Central Pacific, but in observations or analysis, actually there's a bigger gap across the data line. So there's a difference. So if we look at the bias in details, actually, so the figure show you the track density bias and the genesis bias across the whole ocean basin. So with different lead times. So we look at the June forecast, the May forecast, the April forecast. So actually the bias has very similar structures. So you see the too many tropical cyclones in the Central Pacific, but in contrast, there are too few tropical cyclones in the marginal seas of the West Pacific, like the Chinese coast, the South China Sea, East of Philippines. There are just too few tropical cyclones. And also, we also look at the model bias in the translation speed for tropical cyclones. So the lower panel show you the translation speed of tropical cyclones averaged over the whole season. So actually, you see there's a very strong anticyclonic bias in the translation speed. So this is related to the bias in the steering flow. Because the metal phase model normally have very weak subtropical high, that means have a relatively weaker steering flow. So about the internal variability in the tropical cyclone number. So we look at the TC ENSO teleconnections first. So the figure on the right side again shows the observed teleconnections in the RB tracks and also in ER interim. So you see there's probably, I think most of you are familiar with this teleconnection much better than I do. So there's a very strong positive correlation in the Central Pacific, but there's a weak and negative correlation in the South China Sea and also the East China Sea. But if you look at the models, if you look at the model, GLOS5 actually have a too strong negative correlation south of Japan and also in the South China Sea. So that's the errors of the model in predicting these teleconnections. I mean, for the polar correlation, it's fine. I mean, the model is doing good job in the Central Pacific, but just in the South China Sea and also on the Chinese and the Japanese coast, the teleconnections are wrong. So what's the consequence for the variability prediction? So this slide summarize the point-to-point correlation coefficient between the observed tropical cyclone number and also the predicted tropical cyclone number in GLOSI 5 June forecast, May forecast, April forecast. So you see the model have a scale in predicting the tropical cyclones in the Central Pacific and Eastern Pacific work quite well. The correlation coefficient is above 0.7. But if you go to the Japan, southern Japan, in the Taiwan and east of Philippines, the model just have no scale. But surprisingly, you can see there's good scale in the South China Sea. So that's something good for the UK Metal Face, because the Metal Face having kind of climate service partnership work projects with this Southeast Asia countries. So if I took this South China Sea box and look at the tropical cyclone number as function of ensemble size and also at the function of the lead time, you see the model can predict the tropical cyclones in this region quite well. So, for example, for the June forecast, which means 1 month lead time, the model can predict the tropical cyclones with correlation coefficient about 0.5, even down to the 2 months, 3 months lead forecast. The model still have significant scale in predicting tropical cyclones. That's something really encouraging. A quick summarize. So in this piece of work, we look at the so we evaluate the model bias first for the tropical cyclone density, and we found that GLOSI 5 produced too many tropical cyclones in the Central Pacific, but there's too few tropical cyclones in the western and northern parts of the ocean basin. The bias relates to the El Nino type of bias in the large-scale environment conditions. And for the regional scale, the GLOSI 5, the scale GLOSI 5 in predicting TC variability is highly dependent on the model's fidelity in simulating the environment and in-soil teleconnections. So precisely, the model has no scale in predicting tropical cyclones south of Japan and also the east of China, but the model has quite good scale in predicting tropical cyclones in South China Sea and the Central Pacific. So we continue to understand the model bias and the model errors in the large-scale environment, teleconnections, and we're also trying to find other statistical methods or hybrid methods to predict the tropical cyclones east of Philippines and East China. Yeah, so this is it's still ongoing work. So I think I can stop my talk here. I am happy to take any question or comment. Thank you.